and therefore it's our last session, I would like to say a couple of words. Firstly, I would like to thank all attendees for your participation and for your interest. I would like also to thank to trainers and mentors for their enormous role in order to make this course real. And my special thanks to marketing team as well. Even you are quite few for now comparing with the number from the beginning, but I think organizing this course of software testing for complex intelligent systems and autonomous vehicles was quite important and forward step for software testing, especially in Georgian market. Congratulations, all of you. After the seminar, we will share the test, which you can do anytime till the 12th of May. And we will share results on 13th of May. So feel free to ask if you have any questions or will need to clarify anything that you know, which you can use Telegram. And we will share results by mail, and those who will pass successfully, you will get also electronic certificate of this course as well. The good nice thing is that we are also preparing presents for you. It's like under preparation for now, and when it will be ready, we will get in touch with you, and so you will receive the presents from us. Also by last mail, we will ask you to share feedback. We will ask you to fill the feedback form, which is quite important for us. So please devote a couple of minutes and fill this form. And now Levan will lead the last seminar, and before Levan will start, I would like to congratulate once again. Also wish you to have a good holiday and happy Easter. Levan, I think you can start.
Thank you, Natia. So as you remember, on the last seminar, we had some problems with Apollo, and then Alexandre recorded another video as a continuation of that seminar. Did you have a chance to watch it? Great. Yeah, so today we will be continuing on the same topic of Apollo, and we will try to create some tests using Apollo to kind of check the functionality of the Apollo. Yes, unfortunately, Apollo was still having some problems, so it is possible that it may crash again, but let's see. At least we will go through the code together, and if it will crash, you will still be able to see it in theory. But hopefully it will also work in practice. Let's start by running Apollo. Also, maybe you had any questions from the previous workshop. Okay, great. No questions. Great. Okay, so as you remember, first we start by running the Docker container of Apollo. As you probably remember from the previous workshop, Docker containers are like, it's like virtualization, but you have all the necessary stuff that the program requires together with the program. So it is like really portable container, and it is easy to run on a computer and install, because otherwise it would be a bit harder to like install this Apollo because it has many dependencies and so on. Okay, it is successfully finished. Now we run another command, like as this is like virtualization, it is like in virtual computer. So we need to like open the terminal inside the container to access Apollo. So in prompt you can see that we are inside the Apollo container. Now we have a command for running LGSVL, not LGSVL but Apollo. So for LGSVL, this also runs DreamView, which is this web interface, like that. And let's also run the bridge, which allows LGSVL or SVL, as it's called now, to communicate with Apollo. Okay, yeah, this bridge, it doesn't write anything. If it's like that, it means it's running. Okay, now let's run the simulator. I'm using the new version of the simulator that Alex showed in the previous workshop. So we'll be using API only mode. So we will control both the simulation and also the dream view from this API. It allows us to create the full test case completely in Python without having any manual steps configuring some stuff in the simulator or in DreamView. So for that, we go to simulations. Here I already have API only, but we can go through the process again. So in the new version, you have this asset store where you can find some simulations created by SVL, or it is also possible to see some stuff created by users. Although I don't think we have anything yet from users. So API only. Everything looks good here. Okay, cluster. Yeah, so as it is API only, we do not enter simulation parameters. It will all be controlled from the API. Same is for autopilot. We will also connect to bridge using the Python API. That's it. So far, so good. Okay, now I will create a new folder for our test case. Let's do it on desktop. Let's call it final workshop. Test type. So from here, you should already know we did it like a lot of times already. This SVL stuff. SVL simulator, our host. And I'll be using San Francisco for that. you can check that it is. We have the map for it. Yeah, San Francisco. Or maybe let's use Borregas Avenue instead. Borregas Avenue. So I will use these pawns to get like good positions for spawning the vehicle. Simulator gets spawn and state equals x well state. So we create a new state and the transform of this state will be this first. Okay, it should be spawns, not swans. Spawns. So the first element in the spawns. So ego equals simulator add agent and let's open the simulator. So I want to use this Lincoln, but I want it configured with a sensor for modular testing, which is this one, and we can copy the ID of this particular combination from here and enter it in our code. So this will create this car with this particular sensor configuration. The agent type is of course ego, and our state is the states that we created just now. Okay, let's also create this forward vector. What's wrong with here? GSVO. It's not agent state, it's agent type. State transform. Yeah, you remember this, right? This forward. I'll open the code. Yes, great. Yeah, so we'll need it after a while. Yeah, let's save it. Okay, actually we can run the simulation up to here. We can just select it all and press Shift Enter, and it will run everything that we selected. Connect. So I forgot to run the simulation. So let's run it. API only. And so everything looks nice. So now from here we can start connecting to the dream view and connecting to the bridge, and then we can control the parameters of Apollo. So first, let's set up the bridge. We use connect bridge command. Again, we use localhost because I'm running Apollo on the same computer. And we have the default port. Okay, actually, let's see if it works. Right. So now Now we can set up connection to DreamView, which is this Apollo interface. Let's call it DW. Actually, it's DV. So we create a connection, and we should pass the simulator instance, simulator connection actually that we created. We should pass the agent that we want to control, and we also have the IP address, which actually has localhost as a default and a default port. So actually, if we just specify the simulation and ego, I guess it should work because it has this default IP setup. Great. So now what I want is to set up the map. So right now you can see that it has this different map, and vehicle is also not set. So we will set both of them from API. And let's make sure that we have the necessary maps. So as you know, this the simulator and Apollo, they are separate. So both of them should have the maps. In Apollo, we have maps in modules, data, not data, modules map, data. And here we have a bunch of maps. So we want Borregas Avenue, which we have here. This is the HD map, which contains this map of the of this place and this lanes and traffic lights and stuff like that. So everything that allows Apollo to drive the car around the map. Yeah, so Borregas Avenue is called like that, Borregas Avenue. With a space in between, so it's different from how it is called in LGSVL. So we have command dv set HD map, and here I'll specify Borregas Avenue. I'll also set the vehicle. Okay, let's run this. And let's check. Yeah, so as you can see, it's loaded. We also want to run the modules also from the API. And we do it together with also specifying the destination of where we want the car to go. So let's first create our destination. Okay, where is our car? Yeah, so we can just move it a bit forward. Destination is state position. So our current position plus the forward vector, which is unit vector, times like how many meters we want forward. Let's do like 200 meters, for example, times forward. Okay, and this will just create this variable. And yeah, we also need to specify which modules we want. We can save it in a list. Modules equals control. We want localization. I won't be using perception because it is usually the source of the fail because it's really hard on the GPU. Instead, it will use the ground truth sensors from the simulator. So planning, prediction, routing, and let's also not use traffic lights because we will not be using it for this particular test case. So let's also run it. It will again just create this variable which contains this list. Okay, now we have this screen view setup Apollo where we specify. So we have x coordinate of the destination and z coordinate. So we don't have y coordinate because it doesn't make sense for Apollo because y coordinate is vertical, so it cannot drive the car upward. So we just have x and z. So I will use x-axis of this destination for the x and destination z. And for modules, we use this list of modules. Let's run it. Yeah, so I don't know if you heard, but yeah, here it's entering the auto mode. Yeah, I guess so far it looks kind of fine. Yeah, but it is not really driving. Okay, let's.
You need to run the simulation.
Yeah, right. So let's run it for like 20 seconds to give it time. Come on, Apollo. Okay, let's try to create some road manually. Point of interest. Here, send routing request. Okay, let's run it again. Yeah, so it's not working again.
Can you try to restart planning and routing module?
Yeah. Which ones?
Planning
and
route.
Yeah, we can also check if it's correctly gets the position from the simulator. Oh, okay, now it's working. I see. Cool. Thank you, Alex. Yeah, so it drove. Now we can set up some test case. So we can, for example, put some pedestrian on the road and hope that this car doesn't hit the pedestrian. Hopefully, it identifies it as a pedestrian and it doesn't crash. So let's continue. Okay, so we can use again. We can use this spawn 0 for the position. So let's create NPC state. Non-player character state equals OGSVL agent state. Agent state. And NPC state. Actually, we can just specify it here. So transform. Our transform will be spawns. Now, actually, I want to move it a bit forward. Let's create here and then let's move it forward. State transform position equals current position plus a bit forward. We can do plus equals and let's do 400. 400 forward. Okay. NPC equals. Yeah, I don't really remember the names of the characters. Let's check in API documentation. Or no, actually we wanted to create a pedestrian. Let's create a pedestrian instead. Pedestrians. Okay, so what kind of pedestrians do we have? Vehicles. Where was this list? Alex, maybe you remember it. This list of pedestrian names.
I don't remember where is, but I think one is.
Here. Yeah.
Yeah.
Okay, which one should we choose? Let's choose Pamela.
Yeah. Sure.
So Pamela equals simulation add agent. Name equals Pamela. OGSVL agent type pedestrian. And we want pedestrian state. Let's save it. Okay, let's see how it goes. Do it create? Okay, I think we spawned it too far. Yeah, she's here. Okay, 400 is too much. Let's spawn another one a bit closer. I think like 40 will be enough. Um, yeah, and also let's move it a bit down because it's too high. Transform position Y by 10 maybe. Let's try 15. Oh, I don't see it anywhere. That's pretty weird. Oh, yeah. I think it's not moving it forward. I wonder why.
So you can try to pedestrian to move randomly, just by method.
Well, but where will it spawn? I think then we will not be able to like hit it or like
Yeah.
create the situation. I think it should work. Yes, and pedestrian state position will be equal to this one. Okay, let's try again. Can't set attribute. Well, it still spawns it there. Actually, let's try to spawn it Let's just remove it. Oh, okay, I get it. Yeah, so I was using this pawn 0, the transform. I think we should set it as a position. Yeah, so weird. I think that's still okay because we can move the car so far to like actually hit it. So let's run the simulation so that they fall down. Let's 10 seconds. They don't even fall. That's really weird. Okay, let's try to create an NPC instead. I think these pedestrians have some different kind of positions. So let's see what kind of NPCs we have. Let's do the Jeep. NPC. Alex, do you have any ideas why it is not spawning them at current locations?
I can't even see them. Are they spawning at all?
I guess they are, but somewhere where I can see them. Let's do a bird's eye view. Yeah, I don't know.
Like you can maybe try to spawn it in front of
Spawn
the car.
it just maybe on a different default location. And it is also not giving us any errors, so it should be kind of correct. Okay, here it is now. Okay, now we can just move it a bit back. NPC state, transform position. This should be probably the axis. And let's move it by 10. Another 10. Let's try 25. Yeah, I guess that's okay. So let's run it so that they fall down. Great. So now we can ask Apollo to move the car forward. Let's first try it like manually, specifying the waypoints in Apollo. Then we can try to do the same thing from the API. So first I will set up an on-collision callback so that we get information about collision contact. And in such case, let's raise exception, test failed. Let's register the callback. Ego on collision, call my on collision callback. So let's run it. Good. Okay, now I'll open DreamView and we can specify a point of interest. So where are our cars? Okay, let's move it, for example, here. Central to Northwest, and we should run the simulation. Let's run it for 20 seconds. And let's okay. Yeah, I think it doesn't like that, like we're pausing this simulations. Like normally you would run it everything in just you would run this script fully. Here we are doing one step at a time, so I think that's why these modules are crashing. So Alex, we reset this one, yes? Planning and routing.
Yes, yes.
And now let's retry. Point of interest, yes. Now it started crashing. Okay. Okay. Yeah, so it still has problems, but we can also go through how we can do the same thing from the API. So for that, we should create waypoints, which are like particular points on the map where we want it to move. And for that, we use OGSVL drive waypoint to create some point. Actually, we can use this position of the MPC. NPC state platform. So we ask it to move where the NPC is. We specify speed. Let's do like 8. So these are not in like kilometers or miles. This is some internal number to LGSVL, and we don't want rejection. So, and we use a command to specify it to the to Apollo. So we use ego follow, and we specify the waypoint, and it should be a list. So in this case, we have just one. So point 1, for example, and we can put it in a list, and then it will lists only having one element. We can also just directly do it here. So ego follow point 1, and let's run the simulation afterwards. Let's run it for 30 seconds. Okay, we can, let's try resetting it again, just in case it will work. The vehicle has no attribute follow. Oh, sorry. Yeah, it's actually about it's for the agent. We should use setup Apollo command. So setup Apollo. Destination is NPC state transform X and transform Z and modules. Okay. Yeah, well, it doesn't move, but I think you still get the idea of how to set up it. Problem is probably because it cannot handle the simulator and Apollo together. Yeah, it is unfortunate that we couldn't see it in action, but we actually wrote the full code for a test. So like at the end of this course, we finally have like a full way to test this automated vehicle. Yeah, so we actually got error, so it's just like not responding anymore, unfortunately. Yeah, so I will try to maybe like run it later and put a video for you to see it in action. Do you have any questions?
We have a homework on this to write a test on ourselves.
I guess not, because like as you can see, it is like always crashing, and it is like really hard to get it to work. Alex, what do you think? No, unfortunately not, Akagi. It is only on Linux. If you want to try it out, you can connect to our workstation. As I remember, Anna was connecting here. And like you can try it out yourself. It's always up. I think it's always up. I heard it works on emulator on Windows. Yeah, I think that's possible, but I'm not sure if it will be like working really great. Yeah, I think it needs like really good. We actually have a really good GPU, but like when we are running them together, it is like still sometimes crashing. Yeah, but I think they will make it better in the future updates, because they are always like improving it a lot, and I think it will be better in future. Yeah, so it's unfortunate that we couldn't see this in action, but I still hope that this workshop was productive. So any questions about this workshop or the course in general?
Maybe just to repeat what Nadia was saying. Hi. Sorry, I didn't say hi. Maybe just to repeat what Nadia was saying at the beginning. We will be sending out the final test tonight. And we wish you good luck with it. It's not very hard, so you can absolutely do it. Just do your best. And the deadline is May 12th. And it's a Google form, so you just fill out the form and submit it.
Yeah, so I wish you good luck on the test.
Thank you, everyone, for your time and effort. I think I learned a lot, so thanks.
I'm really happy to hear that. Thank you, Anna. Okay, if you don't have any more questions, I think we can call it a day.
And again, ask all the questions that you have in the chat, please. Okay?
Okay, goodbye, everyone.